Hello everyone, and welcome back to another video. We're doing LeetCode again on linked lists. It's another easy problem, and this one, so it's 83, remove duplicates from sorted lists. Again, same as the other video, I'm just gonna write the code out and now explain each, everything line by line, I guess. Okay, so given the head of a sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. Okay, it's an easy problem because the list itself is already sorted, so we don't need to, sort it first and then figure everything out. So let's just first write the base case, what we have here. So if list is empty or has only one element, return it. So if head equals null, then return head. That's it for the base case. Then next, let's start with the first node, meaning we're just gonna create one. So list node current equals head. Now we're gonna traverse. So we're gonna go through the list basically. While current, what we're doing here is we're gonna make a while loop and we're gonna compare the first node with the second node. So it'll be current and current.next. Boom, 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 boom. With this while loop, we're checking the current, and if the current.next is not pointing at a null, that means the list is still continuing, right? So we will continue with the while loop. Let's make another comment. If the current node's value and the next one is the same, skip. So what we're doing here is we're checking the current node with the current next node, the value. So if current value is going to be equal to current.next.value, then we're not doing anything, we're just going to skip it. So current.next would become current.next.next. Right? So there's the if. Let's also write an else statement. If there's basically nothing else, if like the value are not equal, then the current now is going to be current.next. So we're moving on basically. Otherwise, move to the next node. Then after that, I think that's it. So we just return the list. Return head. Let's see, should be good, I think. Oh, wait, what? Oh, you gotta be kidding me. I gotta log in. Bruh. Okay, whatever. Perfect. Okay, so, okay. All right, so let's go through it. So right here, it's already explained, right? We first have to check if the head is null, right? So if head is equal to null, that means the list itself is empty. And if that's the case, there's nothing to do. We just return the head. But if the head is not null, we'll continue with the rest of the code, correct? What we have here is we simply just create a list node pointer and we called it current. And what the pointer is just gonna be the pointer is gonna be the one that's gonna like travel through the linked list. And right now we have the pointer pointing ahead. So in here, what we're doing here is we're going to enter a while loop, and it's going to continue as long as current is not equal to null and current.next is also not equal to null. So if we take example 2 or example 1, for example, example 1, the current is going to be pointing at 1 first. So the current is not equal to null and current.next is also not equal to null. So if that's the case, then the while statement is true. So we continue. Now inside, we have the if statement, if and else statement. What we're doing here is we're going to check if the value of the current node, which is current.val, is the same as the value of the next node, which is current.next.val. So we're checking these two, correct? If these two, if for example, on example 1, what we have here is current.val, which is 1, and current.next.val is also equal to 1. If that's the case, then the current.next will just become current.nextNext, which is 2, right here. This way, it just means that current and current.next are duplicates, and we remove it. But we don't really need to physically remove it. We kind of just have the pointer skip it, basically. It's a lot better that way. So the pointer for current.val would just be pointing out current.nextNext right here, right? If the value are not equal, meaning there is no duplicates, we just move the current pointer to the next current pointer. But obviously on example 1 is not. We can do it on example 2, right? So with example 2, the while statement is true because we have the pointer current and current.next. They're both not equal to null. Now current.val is 1, current.nextVal is also equal to 1, so they're equal. So the if statement is true, meaning the current.next would now be pointing at current.nextNext. Now we're still in the while loop because the current is still 1, but current.next is also not equal to null. Now we're back at the if-else statement, and this time the if statement is not true, meaning the else statement will be the true. So we're doing the else statement, meaning we're going to move current to equal current.next. And since current.next is equal to 2 now, we basically move the current pointer to 2. And then we start all over again. And then it's going to keep continuing until the current.next hits null. And when that happens, basically it closes the while loop, and then the loop basically, it just tells us that we have went through the entire list, checking for duplicates and removing them or skipping them is a better way to say it. So in summary, and then we just return the head because the head remains unchanged since all we're doing is we're modifying the next pointer of the node, not the actual head of the list. So what we're doing here is we're returning the modified list. And it's obviously correct because I just ran it, so we should be good. And let's go with the time complexity and space complexity. So time complexity will be O of n. Reason for that is because in the code itself, what we're doing is we're basically going through the entire list. So n is where the number of nodes is in the linked list, right? And we're only going through the list once since it's already sorted. Now space complexity will be O of 1 since we're just modifying the list in place without using any extra space except just for the current pointer, so it'd just be O of 1. So this is a lot easier compared to the other question that I did with the other video, but all these questions are pretty easy to begin with anyway. So all right, thank you guys for watching.